Hello and welcome to this video where we'll go into using dbt to transform the data. We are working with the modern data stack and building this project with job ads. As far as we have come, we have worked with DLT, data load tool, to extract and load the data from the API into the staging layer of duckdb. Also, we have done dimensional modeling. So you can watch the previous videos in this series. I will also link this with the dimensional model. We will follow it and create our star schema in dbt so that we make the transformations based on this model. However, we won't implement all of the dimensional model. There might be something that is left for you to implement yourself and add to the dimensional model if you think something is missing. I won't implement everything in dbt because I want you to try to implement the rest of the model. Let's go into Visual Studio Code and see how far we have come. So this is how far we have come. We have created this dimensional model. You can see that this is the star schema. We have fact in the middle and we have a lot of different dimensions. The idea is that the fact is the main transactions where you have the vacancies and relevance. These are the metrics, and then you have several dimensions. You have, for example, dimension job details, dimension occupation, dimension employer, etc. And this will make sure that we can join them to get more additional information when needed. So this is a very common design in data warehouse. And also we have from DLT, we have extracted loaded data into our data warehouse, which is called ads_data warehouse, duckdb. So let's check that out first. So duckdb-ui add data warehouse.duckdb. And here you can see our, let me create another one. Let's see here. It's demo. So here I picked this data warehouse. So I will do desk to see what we have. And what you can see here is that we have our staging, like DLT, it puts in all the data into the staging layer, which is basically represented as a schema in this database. So then we have job ads. So let's look at that. So from job ads, staging.jobads, you can see that we have ingested 6,300 rows, and from here you have a lot of columns, and you can see to the right here there's a lot of columns and there's a lot of details here. For example, you can look at headline, for example, you can see that it has no nulls, and you can see, for example, logo URL, there are 12% of this column that is null. So that here you can get a lot of metrics that is quite useful. So based on this, based on the star schema that we have, the dimensional model, we will create our dbt modeling. So let me close this down. Let me close that one. I will do Control D. So I have closed my data warehouse. So let's now create dbt. So first of all, I have activated my virtual environment. I need to install uv pip install dbt core and dbt duckdb. Okay, so I've installed those to my uv and it's activated. So I'll just do dbt init. And let me call this job ads project demo. Okay, enter a number for which database. So choose duckdb 1. Okay, and you can see there's a job ads project demo here. Actually, I will call it dbt modeling or dbt transformations, or modeling sounds good actually. We'll call it dbt modeling. So now This is the standard setup that we have. Let's see our models. We'll remove this example here. We'll go into dbt project.yaml. We'll remove the example here. Okay. And this one is called job ads project demo. And this is job ads project demo. So let's go into our profiles.yaml to see that it's correctly set up. So that we will do like this. Code tilde slash dot dbt slash, let's see what it's called, profiles.yaml. And now I've opened this up and you can see I have several projects here. So the profiles is connected to each dbt project.yaml. You can see that through here. This is the name, job ads project demo. You can see here job ads project demo, and you can see the name is job ads project demo, right? So that is where you find the connection. And here you can see that it says type duckdb dev.duckdb, and it's the dev that we're using now. The target is dev, right? Because here is development, and also you have one for production, which can be used when you go to production. However, for the development, we have type duckdb, and I will have the path to it. It's not called dev.duckdb. It's called .. because note that dbt modeling, this is where we are from the dbt when we're running dbt run. So from dbt modeling, we go up a step, .. and we go into this ads data warehouse.duckdb. So ads _ data _ warehouse .duckdb. So we are pointing towards this duckdb file, right? So note that duckdb is a file database. So save this one. And I will go into, I don't need to change anything here. Instead, I will cd into dbt modeling. Note that this is important that you have your virtual environment activated, otherwise you won't have the dbt command. So now I'll do dbt debug. And you can see that all checks have passed. That is good. It means that we have the connection correctly set up. So based on this one, we can start doing our modeling. So let's do like this. We'll go into models. And from the models, I will create several folders. I'll do make dir. I will have one for dimension. I will have one for marts. I will have one for fact and one for source. So when doing this, you can see in the models here, we have dim, fact, marts, and source. And this is where we'll place our models. So let's do another thing here. Let's go into dbt project.yaml and we'll choose how the models will be materialized. So this is job ads project demo. I'll tab in and I'll do plus materialized. I want it to materialize as view by default. However, I want my src to be materialized as ephemeral. And ephemeral means that it's a temporary table, or it won't store in a database. Instead, it will be used as you would do in a CTE, so that you would have a temporary table that you can access from. So that is what it does. And why do I want to have this as ephemeral? That is because the idea behind the source models, they are taking the data directly from staging and dividing them into several sources. And there's an idea behind this that you are able to see this in the lineage later on, into the data lineage. You can see where the data has flown in order to see all the transformations one by one. And also, when you divide it this way, that you have a source, you're also able to test against your source. This is a super good way so that you can test the source data. Otherwise, the data in staging cannot test it. And if it comes in bad data into your models, then the bad data will propagate, and later on when you're serving the dashboard, there's a risk the stakeholders see wrong data, right? So we don't want that to happen. We want to be able to test the source data. So that's why we have a source. So then from the sources, we will build our dimensions. And here it will be materialized by default to view. However, I want to have a schema here, and schema I want to have in the refined. So my schema refined is representing my refined layer. So remember, we have staging layer, refined layer, and then we have the marts layer, which is the serving. So this is the refined layer. I will have pack. It's also refined. And then I will have marts. It's called marts, right? So this one should be marts as well. So marts, and this is also in its own schema actually. So it's in the schema. So you can see that dbt it works. The source will connect to the staging, and then we have dimension and facts. They are in the refine layer where we do our transformations, and then we have where we pick from our transformations. So you can picture a lineage where the data flows from the staging layer into the refine layer into the layer. And later on, you will be able to connect your streamlit dashboard to the layer. So this is the idea. Okay, and then afterwards, another very important thing you need to do is go into the macros, and you need to create something called generate schema name. Actually, you can see this if you search up the documentation of dbt. This is what they recommend. And what is this? I will copy and paste it in here. So this is a macro, which macro is basically a Ninja templating language for creating reusable SQL code. So basically a reusable function. And this generate schema name is the one that we'll look for when you do run, so that it will generate the schema name. So by default, all the schemas will jump into all the materialized views will jump into dbt, into the main schema or the public schema, depending on which database you use. So by using this one, you see the set target schema. Set schema equals the target schema. And then you do some cleaning here of the name. And what it basically does, I don't need to go into details here. However, what it basically does is that you will get a schema called dim. You will get the schema called back, marts, and source. Not source, actually, because it's ephemeral. What I mean by this, you can look into dbt project. You will get these schemas, actual schemas, refine and marts. If you don't have the generate schema name, I want you to try it out. Just don't have it and see that the schema gets into the, it will get into the wrong schema. But by using the generate schema name, it will go into the right schema. If it doesn't exist, then it generates it. So this is basically the idea. Okay, so let's start with sources. So I'll go into sources. I'll actually increase this one a little bit so that it's easier for you to watch. Creating a file called sources.yaml. So this file is used for defining where the sources are. So we have sources, and we'll have a name, job ads. So then we'll refer to this source by using job ads as the name. And then we'll have schema. Let's see. Schema. Staging. So this one will look into the staging schema of the actual data source. So in the data warehouse, we'll look into the staging schema. And we'll look into these tables. And the tables we'll look into is called job ads, but the name is stage ads. So we have an identifier that's called job ads. So this means that while we're using job ads, and if we use the source from elsewhere, we'll use job ads. And then we'll use stage ads, and it will give us the staging schema and the table job ads. So this works in action like this. So let's create a job ads. So let's do like this. src job ads.sql. First we'll change here down here into Jinja SQL. I'll save this one. In all DBT models, you should start with a CTE. So with stage job ads as select star, and here I'll write source, and dbt power user gives me this snippet. So just enter, and it's source of the source name and the table name. Remember that the source name is this one, job ads. And then the table name is called stage ads. So job ads and table name stage ads. And this is it when we are. So if I try this out, select star from stage job ads, and I run this one, command enter to run it in dbt power user, you can see we get the table. Why do we do this? We do this for different reasons. For example, I could do like this, select star from staging what is it called, job ads. However, since I'm doing that in several places, I will refer to this same source in different source models. And then if I change the name of, for example, I change the name from staging.job ads into staging.jobads2, then I need to change it in every other models. Now, if we change the name, we just change the identifier here. And you can see that these are the same. The names are the same. So by having this sources.yaml, we will help make it easier to maintain when the actual table changes name. Does that make sense? I hope it makes sense, because this will help make it much easier. Okay? So let's pick out the things we want. So I'll go into job ads dimension. You can see that the job ads will pick data from. So the source job ads will be the foundation for fact job ads. So what is important here? Occupation ID, job details ID, employer ID, auxiliary attribute ID, vacancies, relevance, and application deadline. Okay. Actually, I won't make all of them. Instead, I will pick out a few of them to show you. So vacancies, relevance, and application deadline. These are attributes of the fact job ad. So these are very important that I picked, and I will go back to the IDs later. So here I'll show you how you can, in a simplified way, work with this. So I will do like this. duckdb dash UI. Actually, I need to be here because here's the modern data stack and here's the ads. duckdb dash UI ads. And I'll open this. So here we'll do desk and we'll do this one. So here you can see all the columns that we want. And I will pick the columns that I want. I want to have relevance, right? I'll just check. Oh, it's called relevance. Good. So I'll add a new cell here and I will say select relevance from staging.jobads. Like this. And you can see we get the relevance. We had vacancies as well, right? However, it's not called vacancies. It's called number Or actually, I need to run this one. Vacancies. Yeah, number of vacancies. You can see it's called like this. I'll pick out number vacancies, comma this. What else did we have? We had application deadline, right? Deadline, application underscore deadline, application underscore deadline. And I run this one. You can see, yeah, we have number of vacancies. I'll increase this one. Relevance, and we have application deadline. And what else did we have? If we go back to VS Code, we have our model here. We have occupation ID, job details ID, employer ID, auxiliary attribute ID. Actually, I won't implement this one. I will give it to you. I won't implement employer ID as well. I will give it to you as well. However, job details ID and occupation ID we need to implement. And also maybe, yeah, I will pick out the columns for employer ID as well, so that you can implement it yourself. So occupation ID, here is occupation ID. We need to think of a way like this. I will go into this one and I will search occupation. And interestingly, you have occupation label, occupation group label, and you have occupation field label. So these ones, you should check it out. If I give like this, select occupation label, occupation group label, occupation field label, occupation field label from, let's say, stage dot job ads. So here, this is like a hierarchy where occupation field label is the highest one. And then we have occupation group label is the second. And then we have occupation label, which is the finest grain. So there could be several occupation labels in a occupation group label. There could be several occupation group labels in a occupation field label. So this is how the hierarchy works. So then the most finest grain here is occupation label. So then I will pick occupation label as the one that will be the foundation for my primary key. So I will use occupation label and then I will create a surrogate key based on making a hash function of the occupation label. Since I know this, that I want to do this for occupation label, then I should pick occupation label with me. Occupation label in the fact table. And we will also pick the occupation label inside of the dim occupation dimension. That is because this is the basis for the surrogate key. And then we need to have it in both the dimension and in the fact table in order for us to be able to correctly do the joins later on. So we pick out occupation label. And similar for job details, we find out that you should do similar analysis to find out. But I've done that and it's the ID. So I'll pick that one as well. So this ID will be foundation for the job details ID. And similarly for employer ID, the ones that I pick, workplace address municipality, and also employer workplace. So these two together will form the surrogate key for the employer. So this is the way you should think of when you're building out your source table so that you can get this into the fact table later on so that you can create your surrogate keys. Okay, so also an important thing is that we have here, we can see that here we have vacancies, relevance. So we could change the names here so that we have workplace. So let's see. Let me copy this one first. I'll go into source job ads. I will remove the select star. And then I will remove the from. And now I can do a Shift Alt F to auto format it. And I'll run this one in. It doesn't work because it's locked on. I need to close this down. Then I will run this one. And now it works. And now you can see occupation label, ID, blah, blah, blah. So we changed the name of number of vacancies as vacancies. Basically like this. The other ones I can keep it as it is. And now I'm done with my source table for my source job ads. And I will make another one. I'll make source, let's see, job details. .sql. Language, change language mode, Jinja, SQL. So with stage job details as select star from source, and here the source is the same as before, job ads, stage, let's say stage ads, right? And let's try it out. So select star from stage job details. And we can see, yes, we get everything here. Okay, so similarly here, we should pick out different columns. And I need to create my key based on the ID, right? So ID, I need to pick out the headline. So you can see we have the headline here. I will pick out description text as description. And you can see there's a text here. And the thing is with sources, usually you don't do much transformations. You pick it as it is. But I think changing the name is, giving it an alias is quite okay transformation to do. All other transformations you do in the refine layer. And here is also, you should continue look up in duckdb what type of columns there are, which ones you want to pick. But it's basically formatted as description HTML. And so basically what you do is you follow this job ads dimensional model and you see the job details, what we have description HTML, we have description, employment type, duration, blah, blah, blah. Right? So I close this down and we continue here. We have a duration label as duration, and we have a salary type label as salary type, salary description as salary description. Let's see, this one is actually the same, then I don't need to do that. Working hours type label as working hours type. You can see all this underscore is basically the result of DLT. It's unnesting the nested data from the JSON. So I run this one and it doesn't work because there's a syntax error somewhere. There's point. Instead there should be a comma. Okay, it works, yeah, and then I continue here. Scope of work min as scope of work min. Continue this one, and here is max. Yes, and I'm quite satisfied with this one. So you can see there are some null values here. These are the null values. Okay. So now we have the sources. So if I run now terminal. dbt run. It found 2 models, 1 source. So these are the 2 models. This is the source, 427 macros, okay, and it says, it doesn't say anything here, but we should check out. So let's have a look here. And if I do desk, you can see that nothing happened. Why is that? Because we have it as ephemeral, right? So it doesn't materialize into any views. So it's first when we choose the materialization as view, then we see it here. So then you might think, okay, this doesn't help much, but we will see in the next lecture where we'll go into making the facts and dimensions that you can get from the source data. So in this video, we have gone through setting up the dbt part of the project. We have used the dimensional model and starting building out our sources. So the sources will be the foundation for the fact table and the dimension tables, which will be later on the result of which we'll be using for serving our BI dashboards. So we set up a generate schema name, and we also set up so that dbt project connects to the profiles. We tested out the dbui and checked some attributes so that we could add them into our dbt models. And so later on, the sources are created as ephemeral, meaning that it doesn't materialize into views that are stored in the DB database. Instead, it's just temporary tables, so ephemeral, and it will be used as you would be using CTEs for later on when you're referring to it. So you're referring to the SRC models by using the ref keyword later on. Yes, but we'll see you in the next lecture where we'll go into building the facts and dimensions and building the marts. Thank you for this video. See you in the next one. Bye.